Hello and welcome to our lesson on the law of cosines. This is going to be section 8.3 from our trigonometry class. And I guess we'll just jump right into it. The law of cosines is only used when you have a side angle side setup or a side setup. Those are the two situations where you're going to be using the law of cosines. And here I have these designated as the side angle side formulas where you're going to be looking for A, B, or C. And then down here we have the side formulas, again, where you're going to be looking for, in this case, angle A, angle B, or angle C. And without further ado, we're just going to jump straight into an example and see how this works. The first example, here in our triangle, we're going to have angle A, angle B, and angle C. Side A, side B, and side C. And then this is what we're given. We're given that angle C is 40 degrees. Side A is 3. And side B is 4. And I guess it would be nice to know that this is a side angle side for sure. We are definitely given an angle, but to make sure that this is side angle side and not side angle like the previous section, notice that all three pieces that are given are different letters. So we're given an A, a B, and a C. And as long as one of those letters is an angle, if all three letters are different, that is definitely side angle side. Okay? The other thing that I'd like to make you aware of is notice that we are given an angle, but we do not know the side across from it. If you have an angle and the side across from it, then the law of sines will apply. But since we do not have any angles and the side across from it, that's how we know the law of cosines will apply. So then the next step, I guess, is trying to figure out which one of these three formulas we're going to use. Turns out it's pretty easy. Whichever angle you're given, you're going to find the related side first. And that's going to tell us that we're going to be using the last formula because we're trying to find little c. Do you see what I'm saying? And from here, it's a piece of cake. We're just going to take that formula and plug and play. So that's going to say c squared equals a squared plus b squared minus 2 times a times b times cosine of c. And then the next step, we're going to have to get rid of the squared. So we're going to have to take the square root of both sides. And finally, we can get little c, we can get side c by putting all of this into the calculator all at one time. Here we go. We've got the square root of 3 squared plus 4 squared minus 2 times 3 times 4. I'm going to go ahead and put a times, you don't have to, times cosine of 40. Remember, since this angle is a degree, you need to be in degree mode. And when we hit equals, we're going to get a decimal. Remember, the instructions are going to tell you where to round. All of my examples that I do in the video, I'm just going to go ahead and round to the nearest tenth. So that will be 2.6 rounded. And that gets us the value for little c. And then the next step is to find either angle A or angle B. And it turns out that it doesn't really matter which one you find first. Okay, but it sort of does. Let me tell you what I mean by that, okay? If you notice, side B is the biggest side. So that means that angle B will be the biggest angle. What I'm about to say is important. If angle B happens to be greater than 90, and you use the law of sines to try to find it, you will not get the right answer. The law of sines will not produce an angle greater than 90, and that's based on the restrictions for the inverse sine function. So, what I'm going to do then, since angle B could be greater than 90, I'm going to go ahead and find angle A next, because if there is an angle greater than 90, there can be only one of those. I don't know if you knew that or not, but if there is an angle greater than 90 in a triangle, you can't have two angles greater than 90. That would exceed 180. So angle A is a safe bet, and we're going to go ahead and use the law of sines to find angle A. So here we go. Sine A over A, sine C over C. And then once I have my proportion set up, I can cross multiply and solve. And that's going to give me 2.6 sine of A equals 3 sine of 40. Divide both sides by 2.6. Sine A is, and let me pull this over here so I can use my calculator. And we're going to have 3 sine of 40 divided by 2.6. And again, rounding that to the nearest. Now listen, this is an intermediate step, so we need to take that to 4 decimal places at least. 0.7417. Any intermediate step, you really should round it to at least 4 places. And then we can bring the sign over, which will make that the inverse sine of 0.7417. And we're going to have to bring up our calculator one more time and do the inverse sine of the previous answer. I do like using that previous answer button there. And this is the final answer, so we'll round that to the nearest tenth, 47.9 degrees. And now angle B is super easy because it's the last angle. We're just going to take 180 and subtract the other two answers. And then again, I'm going to pull up my handy dandy calculator just to do that arithmetic. Oh, SD 92.1 is my final answer. And notice that angle B was greater than 90. So if I would have used the law of sines to find angle B first instead of A first, I would not have gotten the right answer. So I'm warning you. If you want to play it safe, use the law of cosines to find the remaining angles, because the law of cosines will produce angles that are bigger than 90. Because if you remember the restriction on the inverse cosine, it produces angles from 0 to 180. So that would be a safe bet. Anyway, let's move on and look at another example. That one is done. We found all of the missing pieces. All right, next example. Again, with our three angles, ABC, and our three sides. And this time we're going to be given A is 20, B is 29, and C is 21. So notice this time in this setup, we're given all three sides and no angles. So that is going to be the side setup. And you basically get to choose whether you want to find angle A angle B or angle C first. It doesn't matter which one you find first. And so what I'm going to do, I'll tell you what, I'm going to find the angles in order from biggest to smallest. So since little b has the biggest side, angle B will have the biggest angle. And so I'm going to start with the middle formula that says cosine of B equals, and then all I have to do is plug and play. So what does that say? That says A squared plus C squared minus B squared all over 2 times A times C. So far, so good? Next step, remember we're trying to solve for angle B, so we're going to have to move the cosine over, which will turn that into the inverse cosine of. And now listen, you can either put all of this stuff in the calculator, or you can calculate this fraction to a decimal and then work with it. And I think most people may choose to go that direction, so that's what I'm going to show. All right, so with the fraction button, we're going to calculate the fraction first, and then we'll use that value with the inverse cosine. Okay. Oh my gosh, look at that. 0. Wonder what the inverse cosine of 0 is. Anybody want to guess? 90. Hey, this is a right triangle. You know what that means? It means Pythagorean theorem applies. Cool. I think I better check that. So that's 90, right? Pun. Now, let's see if this calculation is correct, because if this is a right angle, that means that side B should be the hypotenuse. And if I do A squared plus C squared equals B squared, if I do the two legs squared added, that should equal the hypotenuse squared. I'm actually going to check and see if that's right, and then that'll verify that my angle B is correct. You don't have to do this. I'm just doing it for fun, just to make sure. 20 squared plus 21 squared, what is that? 841, so that should be the same as 29 squared. And it is. And so what that does is that verifies that this is a right triangle and that angle B is the right angle. Now then, I can either find angle A or angle C, listen, with the law of sines or the law of cosines. I can now use the law of sines because I now have an angle and the side across from it, or I can use the law of cosines if I want to. And I tell you what, since we probably need the practice, I'm going to go ahead and use the law of cosines again. And I did say that I was going to find the angles from biggest to smallest. So the next biggest angle should be angle C. Right? He's got the next biggest side. Side A is the smallest, so angle A should be the smallest angle. So let's plug into the law of cosines for cosine of C. And if I could pull that down where you can see that, you can see as I plug and play. We're going to have A squared plus B squared minus C squared all over 2 times A times B. So far, so good? Now then, I now need to move the cosine to the other side so that we can isolate angle C, and that's going to be the inverse cosine of, and again, I'm going to do that calculation separately. Let's see here, as a fraction, 20 squared plus 29 squared, blah, 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 yada, 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 more stuff. Okay, 2 times 20 times 29. equals, and I'm going to leave that a simplified fraction. Now here's why I want to leave it a fraction instead of a decimal, because if I use the decimal, what I'll have to do is round it off. But if I keep the fraction, that makes it exact. And if I can keep that exact, then that's going to make my answer as accurate as possible. Do you understand that? Anytime you can keep your value exact in an intermediate step, then your final answer will be more accurate. And so now we need to just do the inverse cosine of the previous answer. And now we can round it to 46.4. All right, so let's scroll back up. Come on, computer. There we go. 46.4. And now I think everybody now knows that angle A is super easy. You just need to make them add up to 180. So 180 minus the other two answers. 180 minus the other two angles. Okay. Oh, and I need that a decimal. 43.6. Okay. Oh, and let me remind you of one other thing that I taught when we did section 8.1, the right triangle trigonometry. Remember we said that if you have a right triangle, that the two acute angles have to be complementary. So really what I could have done instead is just taken 90 minus angle A. And you will get the same answer, okay? 43.6. And just again, a side note, remember I said that side A was the smallest, so angle A should be the smallest angle, and it is. And so that makes me feel good about my calculations. And we're done. And what that does now, at this point, I've now covered an example of side angle side and an example of side side side. And since I only did 2 examples, I'll tell you what I'm going to do. I'm going to do one more example, and we're going to do a word problem. Just for fun, we're going to do a word problem, okay? So the word problem says the distance from home plate to the fence in dead center field is 400 feet. So what we know is we know that a baseball diamond is in the shape of a square. Okay, so this would be home. This would be second. And then if I draw a line from home plate through second base all the way out to the fence, then that would be dead center field, is what that would be. And then it says, how far is it from the fence in dead center field to third base? So over here, this would be third base. And we want to know this distance here. Now here's the information that they give in the picture that you can't see from the textbook here, that this is 90 feet. So the baseball diamond, it's 90 feet from one base to another, and the angle at each one of the bases is a square. So notice what this line does going from home to dead center field. That line bisects the angle at home. If that's 90, then I know, whoops, I got rid of, there we go. There we go. If this is 90, then this angle must be 45 because it bisects it. And it said that the distance from home to dead center field was 400 feet. So we know this length right here. We know this length right here. And we know the angle between. Now look at what we've got here. We've got a side angle side setup. And we're looking for the side across from the angle given, and that's what tells us that this is law of cosines. The fact that it's a side angle side setup means that I can use the law of cosines to find the distance I'm looking for. And now what I want you to notice is that these three formulas up here are pretty generic. Really, you don't have to memorize three formulas, you just have to memorize one. It's the two sides, whatever two sides you're given, added minus 2 times those same two sides, and then cosine of the angle across from the side you're looking for. Do you see that? It's a generic setup. So what I can do is I can just say 90 squared plus 400 squared. That's the two sides squared and added, minus 2 times the two sides times the cosine of the angle that is across from the side that I'm looking for. And that's how we can set this up and solve. Now the next step, of course, I got to get rid of the squared. So I need to take the square root of both sides. And that's going to come down to button pushing. Here we go. So we're going to have the square root of 90 squared plus 400 squared minus 2 times 90 times 400 times cosine. And again, you can put the times or you don't have to put the times. It's understood. Cosine of 45. Make sure you're in degree mode. And you're going to need to round wherever they ask you to round to. I'm going to say 342.3 feet. And that's how you can calculate the distance from home plate to dead center field. I'm sorry, that's not the distance from home plate to dead center field. That's the distance from third base to dead center field. Okay, so if you think about it, if you've got a baseball player that catches the ball at the fence and he wants to throw it to third base, that's how far he would have to throw the ball. That's what that tells us. And that's going to do it for this particular lesson. Okay, so if you have any questions or comments, feel free to leave those in the comment section below, or you can text me. And thanks for watching.